Good morning, students. Today we discuss about SQL integrity constraints. So, what is SQL? That is structured query language. Is one of the implementation of retrieve query from the database. So, comes upon constraints. Constraints means it is simply called condition. It also called rules. It is enforced on the data columns of a table. So these are used to limit the type of data that can go to into the table. Able to understood, okay? So simply it's called constraints or the rules. So each column is enforced in the table using in that of table. This ensures the accuracy and reliability of the data in the database. So that is in the advantages of using in a constraints. The constraints could be either column level or table level. So the two level of approaches usually in that of constraints. The column level constraints are applied only by column, whereas the table level constraints are applied to the whole table. So these and all would be applied for in the either column and then table level. So most commonly used constraints available in a SQL. These constraints have used in RDBMS concept, which retrieves data from the database. So in that of SQL integrity constraints, it's used to apply all the business rules for the data table. It's very important. It's only taken from the application of development in a business oriented database. So the constraints can be specified when a table. So each table is first created using the create table statements and then alter table statements. Okay, so these and all is data manipulation language and then data definition languages are there, isn't it? Okay, so data definition languages, how to create a table and then alter the table, and then another that data manipulation languages of insert, update, delete. So another in that in the constraints of how to drop in the constraints. So either in a column level or table level, the columns are applied to the integrity constraints. So the constraints are mostly to make sure that the integrity of the table using in the applied to the table. So what are the constraints are they used in the top SQL constraints, that is not null constraint, default constraint, unique constraint, primary key constraint, foreign key constraint, check constraint, and the index. So the not null constraint, it ensures that a column cannot have null value. So default constraint, it provides a default value for a column when none is specified. The unique constraint ensures that all values in a column are different. So primary key, this uniquely identifies each row by a record in a database table. Then foreign key constraint, this uniquely identifies a row record in any of the given database table. Then check constraint, so user to check the constraint ensures that all the values in a column satisfies certain conditions. Then index is used to create and retrieve data from the database. It's very quickly. So these are all used for the constraints, the development of in a database. Another in that of constraints we have to specify in that column level and then table level, isn't it okay? Then how to define the each SQL constraints in a table. So we take first integrity constraints. So first one is integrity constraints of primary key. So primary key is a unique key of identifies each row in the table. So this is the combination of columns. So the primary key at the column level, column name, data type, then using constraint name, and primary key. So the syntax to define a primary key at a table level. So how to define using in the table level? Constraint name, primary key, column name 1, column name 2. So column name 1, column name 2 are the name of the columns which define the primary key. The syntax with the bracket using the constraint name is optional. For example, to create an employee table with the primary key constraint, the query would be like. So we take example in that of primary key level. So create table employee. So ID, number, name, department, age, salary, then location. So create table name employee. So we have to use the ID number is a primary key. Okay. So also using in that of how to define in the foreign key. So foreign key means it is any column referencing the primary key in another table. This usually identifies the any column referencing the primary key in another table. It establishes a relationship between two columns in the same table or between different tables. For a column to be defined as a foreign key, it should be defined as a primary key in the table which is referring. One or more columns can be defined as foreign key. So what is a foreign key in a column level? Constrainedly the references a table name, then column name. So the syntax to define the foreign key table in table level. So the syntax of constrainedly foreign key, column name, referenced table name, then column name. For example, we use in a product table in order items. So product ID is a constrained product ID. So here in that of using in the foreign key, already create a table that is either manager ID. So using here in that of manager ID is a references of the employee table. So ID number is a primary key. The name, character, age number, then manager ID is a references of the employee table. So here another one that of not null constraint, because it should contain at least one value, is not null. Okay. So null means allowed blank, but not null means it should be carry at least one value. Okay, it means not null value is not allowed. So how to define the constraint satisfaction name? Not null. To create an employee table with a null value, the query would be like, so create table employee ID number name, the constraint not null, then department, age, salary, location. SQL unique. So this constraint ensures that a column or a group of columns in each row have a distinct value. So a column can have a null value, but the values cannot be duplicated. That is called unique. So this constraint ensures that the column or a group of columns in each row have a distinct value. A column can have a null value, but the values cannot be duplicated. The syntax to define a unique key at the column level constantly using any unique. So how to define the table level constantly unique column name. So create an employee table with a unique key. The query would be like unique key at a column level, create table employee. So in the top field name location, it should be unique. So create table employee, ID number is a primary key, name, department, age, salary, then location. So the constraint location is a unique. So unique key at the table level, we create constraint location, unique of location. So SQL check constraint. So this constraint defines a business rule on the column. So all the rows must satisfy this rule. So the constraint can be applied for a single column or a group of columns. Yes. So the check constraint is used in the top to satisfy this rule. So the constraint can be applied for a single column or a group of columns. How to define the syntax to be defining a check constraint. So constraint mean use in a check. What is the condition to be checked? So that is constraint mean check under the condition. So in the employee table, to select the gender of a person, the query would be like check constraint at a column level or table level. So column level, create table employee. So ID number is the primary key. So name, the department, age, number of two, gender. So using gender in either male or female. So salary number of 10. So location character of 10. So the check constraint. So the employee table to select the either the person of male or female, isn't it? Okay, so that is using in the check constraint. Some other example for adult or children. Okay. So the check constraint of the table level, we have to use the constraint gender CK, check the gender in the male or female. Okay. Then another inset of constraints have is specified when a table is created with a create table statement. Use the alter table statement to create a constraints even after the table is created. So dropping constraints. So this is very important, how to drop the table using the table of alter statement. So any constraint that I have defined can be dropped using the alter table command with a drop constraint option. For example, to drop the primary key constraint in the employees table, use the following command: alter table employees drop constraint employee pk. Some implementations may be provided using in the shortcut for dropping certain constraints. So for example, to drop the primary key constraint for the table using in the Oracle database. Okay. So what is the exact meaning of given in the integrity constraints? Okay. So in that of integrity constraints used to accuracy and the consistency of the data in a relational database. So it is handled in a relational database through the concept of referential integrity. So referential integrity is used for primary key, foreign key, unique constraints and other constraints which are mentioned in the table. So integrity constraints are used to ensure accuracy and the consistency of the data in a relational database. Data integrity is handled in a relational database through the concept of referential integrity. So there are many types of integrity constraints are played in the database, that is in the referential integrity. Okay. Okay, the next slide we see the example of integrity constraints. So the first question: create table employee ID. Employee ID is a numeric, not name is a varchar, department name varchar, salary numeric. So you can use the command insert into employee values of 1002. The name is Rose, and then department is CSE, and then employee ID. Okay, so the question is arised, what will be the result of the query? All statements executed. The B is error in a create statement. C is error in insert into employee values. Error in insert into employee values. So given the explanation, the not null specification to insert the null value for the attribute. So the unique specification that lower tuples in the relation can be equal on all the listed attributes. So all the listed attributes you have to add in that of all the table. Okay. So the answer is the unique specification of the relation can be equal to all the attributes. See the next question. The comparison of relation can contain null values are treated as unknown. Suppose all comparisons with a null value are treated as false. Which of the following pair is not equivalent? So given the options x equal to 5, not x equal to 5, x equal to 5, x greater than 4, and x less than 6 where x is an integer. Option C, x less than 5, not x equal to 5. Option D, none of the above. So given the explanation, it does not need much explanation. So for all the values of smaller than, it will be always true. Because if x equal to 5, it is false. So that's the value of answer. Option C. Okay, the next topic is integrity constraints in a functional dependency. So functional dependency using in the database concept of using in the constraints. So determines the relation of one attribute to another attribute in a database. So the exact definition of functional dependency is a constraint. It determines the relation of one attribute to another attribute in a database management system. So it helps to maintain the quality of data in the database. So more difference between in the functional dependency of in between the two attributes, the primary key and the non-attributes of the table. It is simply represent X implies Y. So the left side of the functional dependency is also known as the determinant. So the right side of the production is known as dependent. For example, assume in the employee table, employee ID, employee name, employee address. So in that of each associated with it. So functional dependency can be written as employee ID implies employee name. So the functional dependency in a database using the reflexive rule, augmentation rule. Okay. Yes, basically, in a functional dependency is a classified functional dependency, trivial and a non-trivial functional dependency. So trivial functional dependency A implies B. So trivial functional dependency if B is subset of A. So the dependency is also trivial. So A implies A, B implies B. Consider a table with two columns, employee ID and employee name. So employee ID, employee name using the trivial functional dependency of the subset of employee ID, employee name. So second one is a non-trivial functional dependency. So A implies B as non-trivial functional dependency. So if B is not a subset of A. So when A intersection of B is null, then A implies B is called as a complete and a non-trivial functional dependency. So how to define in the non-functional dependency? ID implies name, the name implies data, but considered in the database. Okay. So apart from that, in a functional dependency, multi-valued dependency. It's trivial functional dependency. Another one is using the non-trivial functional dependency. Okay. So multi-valued dependency in the situation where there are multiple independent multi-valued attributes in a single table. So multi-valued dependency is a complete constraint between two sets of attributes in a relation. So it is required that certain tables to present in a relation. So the multi-valued dependency, we take the example car model, manufacturing year, color. So in this example, manufacturing year and color are independent of each other but dependent on car model. So in this example, the two columns are said to be multi-valued dependent on car model. So this dependent can represented like this. Car model, it implies manufacturing year. Car model implies color. So trivial functional dependency in DBMS is represented as a set of attributes which are called a trivial if the set of attributes are included in that attribute. So X implies Y is a trivial functional dependency if Y is a subset of X. So trivial functional dependency. So take example employee ID and the employee name. Employee ID is a subset of employee name. So non-trivial functional dependency, it occurs the subset of attribute it considered a non-trivial dependency. So company CEO age, the company implies CEO. As we know the company name, we also know the CEO name. So C is not a subset of the company, it's a non-trivial functional dependency. Able to understood? Then transitive dependency in DBMS. The transitive dependency is a type of functional dependency which happens when it is indirectly formed by two functional dependencies. So the two functional dependencies are used the same example in company, CEO and age. Therefore, the rule of transitive dependency, so company CEO, it should hold that make sense because if you know the company name and you know the age. So remember that the transitive dependency can only occur in a relation of three or more attributes. So in that of functional dependency, so using some Rules of functional dependency is reflexive rule, augmentation rule, transitive rule. So reflexive rule, if X is a subset, if X is a set of set attributes and Y is a subset of X, then X holds a value of Y. So in the augmentation rule, when X implies Y holds and this is attribute set, so AC implies BC also hold. The deciding attribute which do not change the basic dependencies. So in a transitive rule, this rule is very much similar to the transitive rule in algebra. So if X implies Y, it holds Y implies Z. So also called in functionally that determines Y. So reflexive augmentation and the transitive rules are using in the functional dependencies. Now we see the example. Given the following relational instance X, Y, Z, which of the following functional dependencies are satisfied by the instance? So a functional dependency is a constraint between two sets of attributes in a relation from a database. So the functional dependency X implies Y. It requires that the value of X this uniquely determines the value of Y, where X and Y are set of attributes. So the functional dependency is a generalization of the notation of a key. So each function satisfies the relational instance of X, Y, Z. This implies X, Y implies Z, Z implies Y, Y, Z implies X, Y implies Z, Y, Z implies X, X implies Z, X, Z implies Y, Y implies X. So this record the value of X. This uniquely determines the notation of the key. So given the subset of the properties in a functional dependency, we have to create an axiom of reflexivity, augmentation, and the transitivity. So how to derive the secondary rules of union of decomposition? We have to write X implies Y Z, then X implies Y, X implies Z. So y uniquely determines x and z and given value of y to find the values of x and z. So y implies x, y implies z, it hold for using the schema. Apart from the rule x, y and then y implies z, the notation of functional dependency. So using some axioms, we have to justify which option is correct. So the option B is true. So using the decomposition of x implies y and y implies z of. So the next question, consider the functional dependency schema of functional dependency. A implies B and C implies D. The decomposition of R into R1 of AB, R2 of CD. So option A, dependency preserving and classless join, but not dependency preserving but not last join, not dependency preserving and then classless join. So the decomposition of R into R1 and R2 is a dependency preserving of decomposition. If a closure of functional dependency is the same closure of functional dependency before decomposition. A simple way to check whether can derive the original functional dependencies from the FD. So in the above question, R of A, B, C, D is decomposed into R1 of A, B and R2 of C, D, and there are only two functional dependencies, A implies B and C implies D. So the decomposition is a dependency preserving. The first preserving of lossless join decomposition. So decomposition of R into R1 and R2 is a lossless join decomposition if at least one of the following functional dependencies are closer functional dependencies. How to we write R1, R2 implies R1. So in the above question, we have to using the decomposed into R1 of A, B, C, D and R1 and R2 is empty, so the decomposition is not lossless. How to form we consider in the functional dependency A implies B and C implies B. So the option which is correct using in the lossless join of decomposition. So dependency, preserving and lossless join. Dependency, preserving but not lossless join. Not dependency, preserving and not lossless join. So conclude that the decomposition of R1 R2 the dependency preserving of decomposition. So here to write the form of functional dependency. After using check whether the original functional dependency is from the database. Okay, thank you students. Today class we discuss about an SQL integrity constraint. Thank you.